You're welcome back. So in this video, we'll be looking at how to find the magnitude and the direction of vectors. So if you have U to be AB, be a vector, then what is the magnitude? We say the magnitude is just given by this formula here. Is given by this formula. The magnitude of A is just the square of the horizontal plus the square of what? The vertical component. So this comes from here. If you have a vector, let's say you have a vector, let's assume the vector, let's assume the tail starts from the origin. So we're going to have a vertical component of the vector, which is going to be B. The horizontal component is A. And then you have theta. Theta represents the direction. So the magnitude is simply the length of the vector. And you can see that from Pythagoras theorem, you have this is going to be the square of A squared plus what? Plus B squared. So square the horizontal, square the vertical out, and take the root. Now for direction is given by theta. But what is this theta? The theta has to be a positive angle. It must be positive, and it must be an angle formed between the positive x-axis and the what? And the vector itself. So you can see that if you are in the first quadrant, this theta will be our direction. So that is why you see if you are in the first quadrant, you can find theta, right? And from here, you can see that tan theta is equals to just B over A. Now this is for the vector in the first quadrant, but you can have a vector in the second quadrant, you can have it in the third quadrant, you can have it in the fourth quadrant. So that is why we need this chart. Let me just explain some briefly here. Let's assume you have a vector in the what? Let's assume you have a vector in the first quadrant is what we've discussed here. So in the first quadrant, theta is going to be our what? Our reference, right? And this theta is still going to be our angle in standard position. Because when we talk about a reference angle is always from the x-axis. So it could be from the positive, it could be from the negative. So from the x-axis to your terminal will give you reference. But for standard, it must start from where? The positive x-axis to your terminal. So let's assume now I'll just explain this one. Let's assume we are in the second quadrant. If we're in the second quadrant now, this angle is not, we can find an angle here, theta, but this theta is actually not the standard. It's going to give us the reference angle. So if you need the standard, you will have to what? You will have to draw from here up to the vector. So this is going to be our direction. So you can see now, if you add the purple one and the what? And the red one is going to give you what? 180, yes? It's going to give us 180. But the red theta is our what? Is our direction. So if you want to get the red theta now, it's going to be 180 minus what? The purple theta. So that purple theta is actually what we call the reference angle, right? So it's called the reference angle here. And that is why you can see that you can call it what? Here we call it 180 minus theta 1. So you can call it theta 1, okay? So that is just for the second quadrant. Now let's just go to example and see how these things work. Look at this one. It says find the vector, the magnitude, and the direction of this vector. So to find vector u, we'll start with the magnitude. So let's start with the magnitude. So what is the magnitude? the magnitude is equals to this one, right? Which is just the root of what? 1 square plus what? Or you can say a squared plus what? B squared, which is 1 squared plus minus 1 squared. And this is going to be root of what? Root of 2, right? That is the magnitude. Now, direction. For direction, you just use tan theta equals to what? B over A, which is equals to 1 over minus 1 over 1. So tan theta is equals to minus 1, right? Now, let's try to graph this one. This is going to be something like this. Because we need to know the terminal where the vector is. This vector, the horizontal component is positive, so, and the vertical component is negative. So it's going to be somewhere here. This is going to be 1, and this is going to be minus 1. So we have this one, right? Now, if we do this, we can find this one. We can draw. This is going to be our theta, right? But this theta, is it actually the theta in standard? This theta is not in standard position, as you can see, because this theta is what? Is negative, right? Because we are measuring from where? We are measuring from the positive, but we are coming to the terminal. So this is negative theta. So this is a reference angle, but it's not what? It's not this angle in standard position. So this theta, all you just need to find, let's call it theta star or theta 1. So this is our reference. This is going to be what? You think of an angle in the first quadrant, yes? Or just any angle that the tan is going to be 1. And that angle is simply what? Is 45 degrees, right? So this is our reference. Okay. But now, if you look at this, this is happening in which quadrant? In the 4th quadrant. So if you want to find the standard, it's going to start from here, but it has to go around and come here. So this is the main theta we are looking for. And now you can see that this purple theta plus this red theta, which is already 45, is going to be what? It's going to be 360, right? So it means that our theta actually, which is the direction, is going to be 360 minus what? Theta 1. So our theta is 360 minus 45. And this is going to be 315 degrees. So this is the direction. All right. So let's move. Now for example 2, or for B, the same thing. We can find the magnitude. It's just going to be the square of 1 square plus square. This is going to be 1 plus 3, right? And this is the square root of 4, which is equals to 2. So we're done with the magnitude. Then the direction. So this is the magnitude. Now the direction, we have to use tan theta, right? Equals to B over A, which is just going to be tan theta is what? Is root 3 over 1. So we have tan theta is equals to root of 3. Now, this vector is in which quadrants? The terminal, we can have this. Okay, so this is this one. Now, this is in the first So here is 1, and here is what? Root of what? Root of 3, because this is like in the first quadrant. So this is, now if we're in the first quadrant, you see that our what's the reference and the angle in standard notation, or standard position, I mean, will be the same. So here you can find your reference, which is what is going to be 60, right? This is 60 degrees, surely. Yep. And now if you want to get the theta, so what will the theta be? The theta, since we are in the first quadrant, the theta is going to be theta 1, which is also what? 60 degrees. And this is simply, this vector is in which quadrant? This is quadrant number 1. The whole vector. Okay. All right. Now let's take C. Now, if you look at C, this is -2 and what? -2 and 0. Now, -2 and 0, how do we find the magnitude? This is direct. The magnitude, which is this, is going to be -2 squared plus 0 squared, which is 4, and this is going to be 2, right? And then what next? We can find the direction. The direction, remember, tan theta is going to be b over a. It means that tan theta is just going to be 0, right? 0. 0 over -2. So tan theta is what? Is 0. Okay. But now look at the position of this vector. Let's sketch this. This vector, we cannot say it belongs to any quadrant because you can see the x value or the y value is 0, right? So it's just a quadrantal. It's going to be somewhere here. This is -2. So we have this vector, something like this. Yep. So what will be the reference angle? Remember, the reference angle is just the angle between x-axis and the terminal. So reference, which is theta 1 or theta star, is just 0. Because reference angle is the angle between what? Between the x-axis and the terminal. Now, between the x-axis and the terminal, is there any angle there? No, it's just 0. But now we need the direction. So our direction has to be an angle that starts from the positive, right? X-axis to the terminal. So please take note. So this is our direction. This one is our direction. This is our direction. And what do you think the direction will be in this case? So definitely our direction is just going to be 180 because that is theta. So theta is equals to what? 180 degrees. That is the direction. Okay, so this is our direction. This is the direction, theta. All right, so example 4. Example 4, you have this, and you want to find the magnitude as well as the direction. So magnitude, you just need to know the horizontal component. If you look at the terminal, this is the terminal, we know the point. This is the point, √3 and what? And 1, right? So you can have this. So this is just going to be our A. A is -√3, and B is what? B is 1. So it means the magnitude, which is M in this case. So here we can say magnitude m is equals to the root of what? This will be minus root 3 squared plus 1 squared. And this is going to be 3 plus 1, which is root of 4, which is equals to 2, right? And then we can find the direction. Now, to find the direction is theta, but we cannot get theta directly. So let's call this guy here. Let's find what is inside here. So let's call this one. This will be our reference, actually, which will be the theta 1. Yes. So it means we can see that tan theta 1 or theta bar is what? Is just it's just going to be b over a. So this is 1 over minus root 3. Yep. So what will be theta? So theta 1 in this case, because we need the reference, so it's just going to be 30, right? Which is just going to be pi over 6. Pi over 6. But now, if you look at this, what can we say? Remember, we are in which quadrant? We're in the second quadrant. So our theta is going to be, you see that theta plus theta 1, it's simply what? It's simply 180, right? So what we need is the red theta. The direction is going to be just 180 minus what? Minus pi over 6, right? So I think we should leave everything in terms of pi. So this, I can rewrite this as what? Pi minus pi over 6. So theta is just going to be 5 pi over 6. So this is the direction. Right. So this. All right. So I think that is all about magnitude and direction. So, okay, we will take another video. We will discuss about components, vectors.